All right, still working on exponential equations, and we're trying to solve these equations by getting the same base. So continued on from the last video, we're going to look at these bases and see what can we do to rewrite these bases. So 25, I know that's the smaller number, that's the easiest one, so 5 squared. And if I rewrite 125, that's 5 to the third power. So 5 times 5 is 25, 25 times 5 is 125. So 5, supposed to be a 3. And then y is already here, so don't forget the y. Bring that down. All right, once you get the same base, set the exponents equal. So I've got 3y equals 2, divide by 3. We're trying to get y by itself. Y equals 2/3. All right, again, check these. I'm going to go through these kind of quickly, but I've already checked these and that is correct. So let's look at number 12. All right, so 16 and 8. Neither one of those are prime. And 16 times 2 is 8, but 8 to some power does not give me 16. So in this case, I'm going to have to rewrite both of these to get the same base. All right, so I like to start with the smaller number. It doesn't matter which one you start with, but I'm going to look at this and I'm going to say I can rewrite 8 as 2 to the third power. Now, can I rewrite 16 as 2 to some power? And I can. 2 to the fourth power is 16. So let's start here. Again, if you need to refer to your table, you can do so. But 8 is 2 to the third. And then I've got x plus 2 is already there. Don't forget it. And then 16, again, is 2 to the fourth power. 4 times 4, or 2 times 2 times 2 times 2. So 2 to the fourth power. And then again, bring down my 3x. All right, now that I have the same base, I can cancel my base, and I have 4 times 3x equals 3 times x plus 2. So 12x equals 3x plus 6. And then I've got an x on both sides. So I'm going to subtract. 12 minus 3 is 9x. And 9x equals 6. Divide by 9 to get x by itself. This cancels. 6 divided by 9 reduces to 2/3. Okay, again, I've checked these, so you go through and make sure you know how to check it, but we're going to move on. All right, 4 and 8, again. 4 squared is 16, so I can't rewrite 8 as a base of 4. So I'm going to have to rewrite 4 first. I know that 4 is 2 squared. And leave this as 3x. Now if I got a base of 2, I need this to be a base of 2. So 2 to what power gives me 8? 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power. And then bring down the x minus 1. All right, that becomes 6x. This becomes 3x. Don't forget to distribute. So 3 times -1 is -3. Again, I need to get my x on the same side, so I'm going to subtract. So I've got 3x equals -3. Divide by 3. X equals -1. All right, I'm going to move on, just trying to show you guys some examples of different problems here. All right, so 1/3, I need to rewrite this as 3 to the -1. We did this in one of the last videos. So remember properties of exponents. If you've got something coming from a denominator, that's the same as rewriting that as to a -1. So I'm going to have 3 to the -1 and bring down the 2x. So that means I've got to write 81 now as a base of 3. So I know 9 times 9 is 81. So 3 times 3 is 9 times 3 times 3. So 3 times 3 times 3 times 3. So 3 to the fourth power is 81. And then again, I got to distribute here. So 4 and 2 give me 8x. 4 times 5 is 20. And then negative 1 times 2x is negative 2x. And again, once I get the same base, the bases drop. That's back to the rules when we started the first video here. We looked at how to solve these. So just refer back to your notes if you need to. Here I've got negative 2, so I'm going to add 2 to both sides. So I'm going to have 10x equals, I forgot my 20 here, 10x plus 20 equals 0. So I'm going to subtract 10x to the other side. So it's going to be negative 20. Divide by 10. X equals negative 2. All right, again, you can plug these into both sides and check them. I have done that, so I'm going to move on with a couple more examples. All right, with number 15, we have 8 and 32. So I've got to figure out how to rewrite 8. We've already looked at 8 as a base before, and we know that 2 to the third power equals 8. And since 32 is even, we know that we can get that as a multiple of 2. So 32 is the same as 2 to the 5th. And then 2a plus 1. My bases are the same, so I can drop those. I'm going to distribute the 3 here and get 6a. 3 times negative 1 is negative 3. 5 times 2a is 10a plus 5. And then I'm going to continue to solve by adding 3. 6a equals 10a plus 8. Since I've got my 8 on this side, I'm going to subtract 10. Move my variable to the other side. And 6 minus 10 is negative 4a. So I've got negative 4a equals 8. Divide both sides by negative 4. A equals negative 2. All right, let's look at number 16. All right, number 16, 27. Okay, we know that 27 is 3 to the third. And we know that 243, that's 3 to some power. All right, so this one's bigger than one that we've used. So we know that 3 times 3 is 9, times 3 is 27. 27 times 3 is 100 and something. And then times 3 again is probably 3 to the 5th. So go to your chart. And I'm going to say this is 3 to the 5th times x minus 2. And then this cancels. So I've got 6x. And this is 5x. And 5 times negative 2 is negative 10. Minus 5x. So x equals negative 10. All right. All right, guys, I know I'm going through these quickly, but I feel like the solving equations part's not the hard part. The hard part is rewriting these as the same base. So once we get the base, I feel like hopefully you should be able to run with it from there. So 64 is 4 to the third power. And then here we've got same base, so we add exponents again. So remember, if it doesn't have an exponent, it's assumed to be a 1. So properties of exponents, same base when I'm multiplying, I add exponents. So make sure you put that plus sign in there. All right, so this one actually would be reduced to 4 to the third. So this would be 4 to the 1 plus 4 plus 1. And then my bases cancel. So that would be 3 equals 1 plus 4x. So subtract 1. and I'm going to get 4x equals 2. I'm trying to get x by itself, so divide by 4, x equals 1/2. All right. Here we have same base, so we add exponents again. And when we add exponents, we're going to have one base and 2x plus 4 plus 2x. And then equals, and remember our 81, our 1 over 81, that came from a power on the bottom. So this could be rewritten as 1 over 9 squared. And to rewrite it as a base of 9, we're going to put that as a -2. And again, this is properties of exponents, so just review those properties. I know that's a Math 2 standard, but it is something that you have to be familiar with here as well. All right, once we get the same base, we're going to have 2x, and 2x is 4x plus 4 equals -2. Subtract 4. 4x equals -6. Divide by 4. And x equals -6 over 4 reduces to -3 over 2. All right, last two examples. So I have 1/7. I know that's the same as 7 to the -1 using my properties of exponents. I have a 7 here. 49 can be written as 7 squared. 7 squared is 49. Then bring down the x minus 5. And then same base, I'm going to add my exponents. Let's bring down one more step just to make sure you follow me here. All right, times 7 to the x minus 9. Now that I have the same base, I can add exponents. So I'm going to have 7 to the -1 equals 7. And I'm going to have 2x minus 10. Same base, I can add my exponents. So I'm just going to put plus x minus 9. Same base, these cancel. I'm going to have 2x and 1x are on the same side, so I combine like terms. -10 and -9 is -19. If I add 19 to both sides, I get 18 equals 3x. I'm trying to get x by itself, so divide by 3. X equals 6. All right. Last example. So I have two bases of 4, and 16 can be written as 4 squared. So let's start with that. So we got 4 to the 2x, and then times 4 squared, but it's on the bottom, so it's going to be 4 to the -2. Again, properties of exponents. Need to have those memorized. They come in real handy. All right, and then 4 to the 6x plus 18. Same base, add exponents. 2x minus 4 equals 6x plus 18. Subtract 2x. So I've got -2 equals 4x plus 18. Subtract 18. So I've got -20 equals 4x. Divide by 4. And x equals oh, sorry. Yep, 4x. -20 divided by 4 is -5. I lost my place. All right, so check these. Ask questions if you need help, and good luck.